Earth is defined by its water. It is a rocky planet that managed to accumulate and hold on to vast oceans. For decades, the mystery was how a world so close to the sun's early heat could ever have become so wet. The standard assumption was that the inner solar system was a dry, scorched zone during its formation. Scientists concluded that if water and carbon were to exist here, they had to be imported from the freezing outer reaches of the system. This breakdown illustrates the mixed source theory. It posited that between 6 and 40. Instead, researchers have found that the building blocks of our planet, including the elements necessary for water, were sourced entirely from the local vicinity of the inner solar system. Our understanding of planetary birth must now account for a process where oceans are not delivered by external impacts, but are a native internal feature of the planet's original rocky material. Scientists trace solar system history by examining the chemical composition of meteorites, ancient debris that has remained largely unchanged since the planets first formed. The key lies in isotopes, atoms of the same element sharing the same number of protons but different neutron counts. Comparing these signatures to known space regions lets scientists determine if a rock formed in the hot inner system or the icy outer. Earth's foundational building blocks revealed a match only with material from our immediate local neighborhood. The signature of the outer solar system was completely missing. This evidence supports the single local source theory, meaning Earth was built exclusively from dust and rocks present within the inner solar system. But this discovery creates a new physical problem. Scientists had to explain why no carbon-rich material from the outer system reached the growing Earth. In the early solar system, a sharp divide existed between the inner rocky zone and the outer region, which was dominated by gas and ice. Sitting directly on the boundary between these two chemical zones was Jupiter. As the most massive planet, Jupiter's gravity exerted a powerful influence on the movement of all nearby dust and debris. Jupiter acted as a gravitational barrier. It was so massive that it prevented outer system meteorites from migrating inward, deflecting them away from the sun and the forming inner planets. Because Jupiter blocked those external imports, Earth had to form using only the materials that were already trapped inside the barrier. Earth is a homegrown world. Its oceans and its potential for life were present in its very first building blocks, rather than being delivered by a late-stage cosmic accident. This logic also applies to our neighbors. Mercury, Venus, and Mars were born from this same localized pool of dust, sharing the same elemental heritage. Since the laws of gravity and chemistry are constant, we can apply this local source model to billions of other star systems. It suggests that rocky planets orbiting other stars do not require a specific lucky delivery of icy comets from their outer orbits to become habitable. Future models will now assume that the ingredients for water and life are likely present in the local dust clouds where rocky planets are born. Earth's origin story suggests that the elements for life are a standard feature of planetary formation, making the existence of wet, habitable worlds across the universe far more likely than we once believed.